what we're going to talk about a little bit is, obviously we're familiar with services in IT. We also need to understand that applications, as we know and love them, have changed. And applications are no longer really identifiable single things. They are much more amorphous than that, and we'll explain how that is changing. We'll also have a look at the importance of understanding the interfaces between things. The connections between things become much more significant now. We'll have a look at the importance of distinguishing between the logical and the physical, the intent and the realization. And that needs to happen at a number of levels of abstraction. We'll then have a look at how do we support in moving towards service-oriented architectures, because it's all very well to go through this major transition, but as we've seen, we really need to understand what have we got, where do we want to go, how are we going to transform, and how are we going to manage and govern that transformation. And that takes, as we've just seen, enterprise architectures and planning, and enterprise architectures and planning, how do we do that? A large part of that, we contend, in our organization is through meta-modeling and understanding what it is that you want to manage and how you're going to synthesize that. So we'll then look at the meta-model. Firstly, what is a meta-model, if you're not too sure yet? Secondly, what does it look like? And then thirdly, we'll have a look at the notations that are emerging for modeling system-oriented architectures at the enterprise level. And we'll look at a couple of enhancements to the meta-models that start to implement things like the governance aspect, the process improvement aspect, and so on. Okay, a little bit about our organization. We're specialists in strategy, enterprise architecture, and business process modeling. We've been operating in that field, not under this name, but the precursor organizations for just over 30 years now. And 19 years of that we have been looking at EA. And please bear in mind that the times I've been doing things, as quoted in the introduction, are in parallel. I'm not really that old. Okay, so we have offices in Europe, in Switzerland, Germany, and Spain, also in the UK, USA, and South Africa. And we have associates, partners in Benelux, Saudi, and New Zealand. Nobody yet in India, but we are talking to people like DigiBlitz, and we'll see if anything develops there. We have our own intellectual property, and in fact, Promus as an organization was formed to take global the IP that we've built over the years in the consulting organizations. And that covers tooling, the EvaNet Modeler tool, and unique integrated frameworks. We were talking earlier about business architecture, and I almost wanted to jump up and respond to that question, because somebody said, is BPM not doing business architecture? And my answer is absolutely not. It is a component of business architecture, but business architecture is about the entire business structure. It is about processes, yes, but also business events, business services, business functions, goals and intent. It's about organization structure. It's also about products and product life cycles. It's also about channels and how do you reach markets. And then it also goes beyond the organization into the context that you're operating in. So that includes things like your competitors, your markets, your legislative framework, your economy, etc. So it is a very broad thing when you really start looking at business architecture. When we look at technical services in IT, we have the lowest level services that we've seen are becoming commodities. So databases we assume are in place, networks we assume are in place, and operating systems, again, these are things that today we just assume are there, we can rely on, they work, they're a known quantity. We also have interfaces, and there are two kinds. There's the interface to the user, and we've seen that those need to become standardized if we're going to start offering common services. And the other side is automation. If we want to start connecting all sorts of things together, then they mustn't blow up when we do that. Okay. Now I can walk into a room in this country where I've never been before, with a notebook that's never been here before, I can plug into a wall socket, use the power, it works. Why does that happen?
Standardization.
Because there are some standards. There is a known voltage, there's a known frequency, etc., etc. There are some standards for the kinds of plugs, although those fall down sometimes. But there are standards in place that let us just connect these things together. And because of that, we can do this very easily and simply. So we need to understand how to achieve that level of simplicity when we start plugging services and business processes together. We also talk about functions and applications, and we'll see more that applications are now collections of functions or services. They are no longer cohesive things that we can see and touch. And business process orchestration talks to the need to be able to, as a generic service in IT, take functionality from different places, from different applications, and put it together, orchestrate it into one cohesive offering. So that is becoming a generic capability that we need. If we look at services in business, these are the customer-facing services. So this is what the outside world sees. This is what your citizen sees from government. This is what your customer sees from your business. So when we look at that, we're looking at the services that we provide to customers. We're looking at the services that we provide to other stakeholders, because we have to satisfy a great many stakeholders, not just customers. There are also investors. There are also government. There is also the public at large in terms of public perceptions. There are business partners. There are various people that we need to satisfy. So it's not only customer or client, we call it stakeholder management. Everybody that you have to satisfy that is external to the organization. To other business units, because very often your organization, as you have in government, and as we've heard, you have a federated government, but then you have unique state governments. Now, those are going to be providing services to each other. And you have to think about anybody else who is going to use your service also as a client, as somebody who will have requirements, who will need service, who will have certain requirements from you. So a very good place to start our modeling is, in fact, looking from the outside in to say, how does the world see us, and what do they want, and what are they going to give us in return? So when we start modeling with an enterprise, we very often start off with that list of stakeholders, and we say, who is out there that wants something from you, and what are they going to give you? Okay? And then we analyze the stakeholders, we analyze the net inputs and outputs from those stakeholders to say, what are they going to give you, and what do they want in return? So you as a citizen, for example, are going to pay some tax or some fee, and you want a service, a license, or some information, or a healthcare service, or whatever it happens to be. Somebody else as a stakeholder may want something different. An investor is going to provide you with capital, and they will want back capital growth, return on investment, and so on. So we look at those net interactions between you and the outside world. Okay? Having got those, we would then look at, for each of those stakeholders, what are the events that they participate in? In other words, what interactions will they have with you as an entity? And those can include things like coming to get a quote for a product, ordering a product, returning something that you're not happy with, engaging you for a service, etc., etc. So what are the events that will take place between a stakeholder and yourself? After that, you then start to say what services must be provided in the organization to meet that event or to satisfy that event, and then how are those services going to be provided? And that's really where we start this journey down the stack, if you like, of service orientation and service provision. We also need to understand that we ourselves are consumers of services. We consume certain services internally. Some of those are those technical services such as database access, network connectivity, power, all of those sorts of things, printing services. When I started out in the IT industry and you wrote a program, your program was the only thing running in the machine. Okay, you didn't have an operating system, you didn't have file management, you didn't have communications management, you didn't have a database system. You wrote everything that ran in that machine, mainly because there wasn't much room for anything to be in the machine. So you wrote everything from top to bottom. Over the years, we've added commodity software around the application. So the application itself has got thinner and thinner, and around it we've now got operating system, file system, database system, transaction monitor, security software, etc., etc. Yeah? So our application, as a proportion of the total amount of functionality that is running, is reducing and reducing. Yeah? Today we have applets running inside things like a Java virtual machine or a container, a J2EE container, and that provides all the generic services for you. So it provides connectivity, it provides networking, it provides security, it provides runtime support, it provides your authentication of a user, it provides user interface mapping, etc., etc. And that is correct. So what we are doing is we are bringing the application down to just that functionality that is unique for the particular business problem that we're trying to solve. Does this make sense? What we now need is we can create those components that we can deploy into these containers around the organization, or in fact find outside the organization. And we now need the mechanisms and the tools to be able to compose new systems, new processes, new services from those collections of components that are available, either that we've developed or that exist in the enterprise or that are available somewhere else in the industry or somebody else is running as a service. Okay, so that is very key, that we need to understand our role as service consumers as well. And typically our business services are going to be supported by a whole range of services underlying them at the application level, at the information level, at the technology level, and we will use a whole range of those. When we talk about applications, they are no longer monolithic or isolated. It used to be when somebody asked, where is the debtors system or where is the billing system, somebody would say, well, it lives on that mainframe. It is these 15, 20 programs. Yes? And that was a system, and you knew what it was, and you knew where it lived. It was written in one language, and it accessed typically one database. And that was the good old days in the 60s, 70s maybe. Okay, over time, applications are no longer monolithic. They've become modular, and they've become distributed. Yes? So today, it's far more likely to find that part of your application runs on a notebook, part of it lives on an application server, part of it lives on a back-end database server somewhere. So your application is actually now consisting of multiple deployed components that reside across a network. Okay, we're not finished with that story. We're still moving down that track. And in fact, what's happening today is those components are now becoming more standardized with technologies like Java, .NET, etc. They are also becoming heterogeneous in the sense that they will be written in multiple technologies. So we might have some components written in .NET, some components written in Java, some components written in Ruby, whatever it happens to be. The key thing is, how do we get all of those components to talk to each other? And that is the job of things like web services standards, where we have ways of describing the component in terms of its services. That's done through WSDL, the Web Services Definition Language or Description Language. We have ways of publishing the availability of the component or the service through things like a UDDI library, Universal Description and Discovery Interface. And we have ways of invoking the functionality or the service provided by a component across a network and independent of technology. And that's provided by things like SOAP, the Simple Object Access Protocol. So those technologies give us web services, and they are technology independent in the sense that we can use components from various technologies irrespective of where they are and which language they're written in. Okay, so that is some of the underlying technology we can use. Sometimes these components are not ours. So when we look at an application today, it will have some components that we've written. It will have some components that we got from a library. It will have some components that we haven't written that exist somewhere else on a network. We may not even know where they are. We just have an address like a URL in a web browser, and we invoke the component. It returns a response. We don't know where it is. We don't know what language it's written in. We're just using it. Yeah? There is one thing you have to be careful of course. It's just like outsourcing any other service. You need to understand, is this thing going to provide the service for you? Because you might find a very useful component that does, let's say, currency translation, and you build your application to use it, and you test it, and it works fine. But then you deploy your application, and you find that this component is actually written by a university student. It's running on his account at a university, and it's only available while he's there during the semester. Okay, and it's not going to handle your 10,000 transactions a day that you're planning for. So when you start to consume external services, you've got to start thinking about then, okay, service level agreements, where do they live, who maintains them, how reliable are they going to be, are there any costs associated with them, etc., etc. Security, if you're sending sensitive data to them, and so on. Okay, so we need to start thinking about applications as just it's like a lasso, a rope we put around a bunch of functions or services for a time. So an application is no longer a thing that is going to be built and live for 20 years. It's going to be something that we pull together this month, okay, from a whole bunch of services that we happen to find useful, and we define something that calls that an application for now. Yes? And we will typically do that in some sort of business orchestration tool. Once that process changes, or if our goals change, or if new services become available that we find attractive, we might amend or dissolve and reconstitute that application. So an application is going to be a movable, evolving thing. It's not going to be a set of code that you wrote and is maintained over 20 years. And that may get beyond some of these questions of, when do you retire an application? Because the application won't be the same kind of animal. The application will evolve over time, and some of its components will disappear and be retired and disappear, but the concept of needing that service and that functionality in the business will continue. It may be met another way as we go along. So they're going to be much more malleable, like amoeba. I don't know if you've ever watched amoeba under a microscope. They sort of split and divide, and they move off, and then they meet some other amoeba, and they join together, and so on. Okay. And that's more how I think of applications these days. They're going to be things that form. They exist for a while. They merge with other things. They split up. They change their shape. And that's how flexible we need to be. Okay, we also need to think about logical applications versus physical applications. Now, that's a distinction we didn't make in the past. When I started working in enterprise architecture, you said, we have an architecture, we have an application architecture. What applications have you got? We found the things on the machines, and we said, you've got a debtors system, you've got a billing system, you've got a this, you've got a that, a stock management system, and so on. Over time, we've discovered that you need to separate the logical application from the physical code. The logical application is what it does for the business. Okay? The physical code is the implementation of what is doing it now. And that will change over time. Okay? So a logical application is something like billing or subscriber management or customer master data management, call center. That is a logical application. A physical application is something like SAP or what's a call center application? Maybe, what's that one? There's a very popular one that's horrible underneath. Anyway, but you know what I'm talking about. So we need to separate that concept of a logical set of functionality that we want from a physical thing that is the code that's deployed. Also, components can very well be part of more than one application. If we need workflow, we probably need it in our subscriber management system, we need it in our problem resolution system, we need it in a property development system, etc., etc. We need that generic functionality in many, many places. So there's no reason why we can't use the same components underneath to perform similar functions in different applications. So again, we can get the benefits there of reuse. And components can be replaced without impacting the overall service. I think that's a very, very important concept and a very important thing to realize. If I want the service that's provided by the wall plug, I plug my appliance into the wall, I get power at a known voltage, at a known frequency, up to a certain level of current. Yeah? And that works for me. And that's all I need to know about that thing, is it will provide that power for me, provided my plug fits the socket. Yeah? How that is generated behind the scenes, I don't care. I don't know, and I don't care. If it's a battery that's being converted to AC and, provided, that's fine. If it's a generator sitting in the hotel, that's fine too. If it's a generator sitting, somewhere in the north of India, driven by a hydroelectric dam, that's fine too. Okay, I don't really care, and I don't need to know how is that provided. Okay, we need to get to the same level with software. I want to be able to say from my application, I want to authenticate a user. Here's the credentials he's providing. Give it to a service. The service must go off, do the authentication through whatever algorithms, through whatever standard techniques it wants to, look up whatever repositories it needs to, give me an answer back. Simple answer, yes, he's identified, or no, he's not. Yeah? Again, I don't need to know what technology that's written in, where it is, what database it's running on. Doesn't matter. I just want to be able to say, this guy, is he good or not? Yes, no, I move on. Yeah? And we need that same kind of functionality at so many points in our applications. So we want to be able to plug and unplug applications or components seamlessly. Looking at the planning versus realization, I just wanted to make the point here between the logical and the physical. If you look at an electronics engineer, he works typically at the level of this logical circuit over here. So he's working with kinds of things. In other words, a transistor, a capacitor, a resistor, and so on. So he will be looking at the kinds of things and the values, the parameters for those things that he needs in order to make the logical circuit work. Yeah? Transistor performs the function of a switch. Capacitor can hold a charge. Resistor, reduces current, and so on and so on. So using those logical constructs, he'll build a logical circuit, and that is independent of implementation, technology, or detail. Yeah? And he can say, this will work. Somebody can go and build this thing. Then we're going to have that realization expressed at a physical level. It's going to turn into something like a circuit board, or with greater miniaturization, a chip. Yeah? Now, again, we don't care really whether this circuit looks like that or looks like this. In terms of the logical function it performs, it could do exactly the same job. Yes? Okay. But it is important that we understand the mapping between these two things. So we might implement this with today's technology, or 10 years ago's technology. We might have implemented like that, and it works, but it's bulky. It uses more power than we want. It's not as reliable as we might want, etc., etc. Today, we can replace that same logical thing with this much smaller, much more efficient, much more reliable component. Yes? Okay? But logically, we can unplug this guy and plug that guy in. No change to the overall device, the overall function it's performing, the overall process around it, etc. All right, let's get now to the concept of meta models. Behind doing enterprise architecture is the concept of a meta model. Meta because it's at a higher level than a content or a normal model, and model because it relates things and describes things. So we'll find in our meta model, that's on the left side of the picture, concepts like application type. Is this a transactional system? Is it a decision support system? Is it a multimedia system? Those kind of things. What is the application function? We've just seen that we want to describe applications in logical terms as well as physical. So an application function would say, I must be able to bill a customer, or I must be able to authenticate a user, or I must be able to do X, Y, or Z. Then down here we've got an application component, which is physical, and that's going to say, I am transactional, and I am, for example, an authentication function. So that's a physical application component, and then that component might be part of a scenario in an architecture plan, and between the application and the scenario we want to know what is the status of this in that scenario. This is part of the governance. So in a given scenario I might say this application for the low growth scenario is adequate, it performs well, it's fine, but for our high growth scenario this application may not be adequate, we'll have to replace it with something more efficient or performant. Okay. So the meta model describes all the concepts that we need to manage, the relationships between them, and it can exist both at a logical level, these are logical constructs, and a physical level, these are physical constructs down here. Then once we'll normally find that the meta model, this is just a very, very small fragment to illustrate the concept, it covers the domains of business, process, application, information, technology. It has this distinction between logical and physical, and it maps the layers, if you like, of support as we go down. Normally there can also be a mapping to a notation of how we want to represent things in the architecture, and I'll get into that towards the end of the talk. Over on the right, we can then use the meta model to develop content models. So if you like, the meta model is a container which holds the things that you model. So each concept in the meta model is like a pigeonhole into which you can put articles or objects of a certain type in your actual content models. So here we've got, in the content model, we've got transactional as a kind of system type. We've got the fact that that categorizes Bankmaster as a physical system component, and that is providing a function of retail banking. And then down here, that is part of our 2006 optimistic scenario, and the relationship there is that during this scenario we'll upgrade that to release 3. So this is part of our governance plan. Okay. Normally now, how can we help you as a vendor of frameworks and tooling? What we can do is we can provide this meta model. We can provide usually the categories for you in this space of the content model. So these are reference frameworks. You will have to provide this content over here. In other words, how do these reference models map to your particular world and your particular future? When we start to look at service orientation in the meta model, we really need to see services at a number of levels. For example, a logical business service, something that you offer to a client or a stakeholder. A logical application service, something that an application does to support a business service. A logical information service, such as providing a customer's address. Yeah? That is an information service that is necessary to satisfy the application. And then a logical technical service, that is something that helps the information or the application service to do its job. So we see a whole stack of business service supported by application service, supported by information, supported by technical. Over on the right, we've got the equivalent physical services. So some of our business services might actually result in physical business services such as mailing something or faxing something or delivering something. Our logical application services are realized through physical application components, and our physical technical services are realized through physical devices, system software, and other technology. If we put an example onto that, over here, I might want to send a contract to head office. That's a logical business service. There might be a physical business service over here of actually faxing a particular form to a particular telephone number. Okay? Down here, I want to validate and capture the contract. That is something an application must provide. And physically, that might translate to screens CON 002 and CON 003 in the contract system. Okay, so these are application services that will satisfy this logical requirement over here. I want to store a valid contract. That's a logical information service. Over here, that might involve creating a contract object in the contracts Oracle database, and depending if it's a new client, creating a client object in a CRM database. And down here, I want to manage my persistent data. That's a logical technical service I need. And over here, there's a physical technical service which is concerned with our Oracle database administration, our Oracle backup and recovery, and so forth. Okay. So we see a logical stack and a physical stack and a realization mapping across those. Of course, for some of these, we have the web services definition or description language. For example, how an application will call on another application, or an application will call on a logical information service. So WSDL can describe some of these interactions, but what we need is equivalence for higher level service definitions. And this is some of what, for example, Budeb is doing in the e-government space, is to define things like what will the protocol be for one government department to invoke information from another government department, properly identify itself as part of the government, and get a meaningful answer. Yeah? So the mechanisms are there technically. What we need now is the application standards and the business level standards for those interactions. We also need, for the governance, as was pointed out earlier, to be able to trace things and to manage things and govern things. So to be able to trace, we have to have the realization of the services from the logical to the physical level. So we need those relationships managed somewhere, typically in a repository and in an EA tool. So we would want to know this logical service of billing a customer. How is that realized? And once we start mapping that, we very often find inefficiencies and inconsistencies, because we'll find that that logical service is actually provided by 5 different physical systems, which all think they're doing the same thing, but which aren't. Okay? So we'll often find inefficiencies, we'll find redundancies, we'll find inconsistencies, where, let's say, a property tax is calculated in more than one place, and the answers are not the same. Yeah? So those are the kinds of things we'll find. We need the decomposition of services to lower supporting layers. So we should be able to say, if I'm going to take a server out of operation, what business processes, what end user services could that affect? How are you going to know that? You've got to have that mapping that says this technical service supports that application, which supports this process, which delivers that service. Okay? You've got to know the composition of services into processes or applications, and also the use of system software products underneath that. And the support of services for products. So not only do we need to map to services that we offer, but also products, if we're in a manufacturing or a product supply environment as well. And we must be able to categorize by things like delivery mechanism or technology. What all do I run over Corba? What do I run over SOAP and TCP/IP? So that we can make those decisions about technical infrastructure, volumes, reliability, backups, redundancy, all those things. We need to know how are we using that technical infrastructure, what does it support, therefore what can we afford to spend on it, how reliable must it be, etc., etc. Okay, and we'll achieve some of this again through the repositories and the tooling, etc., cross-reference matrices, graphical models. Once we've got meta models and models that describe the architecture in terms of services and across the different domains, business, application, infrastructure, technical, we'll find that we can enrich those then with a number of other dimensions. One is intent. What are the benchmarks? What are our measurements and our metrics for our performance today? What are our goals? What are our objectives? Where are we trying to get to, and how are we going to get there, and over what time periods? You can also map responsibility and ownership. As was pointed out, we need to assign accountability and responsibility. So having these models in place allows us to map to things like business units and roles that are responsible to make sure these different things run at all levels. So you can say the business service is the accountability of this business unit owner. The application service is the responsibility of this application manager. The information service is the responsibility of this database administration function. The technical service is the responsibility of the operations manager, and so on. Yes? You see how it cascades down. Okay. Then we can also monitor cross-cutting concerns, and these are three of the biggest issues in business today. That is risk. How do we manage risk? How do we manage cost? And how do we manage and improve quality? And what you'll find is that all the things that you want to worry about risk for and cost for and quality for are already in your architecture picture. What do I have risk for? I have risk for a product. I have risk for a location. I have risk for a process. I have risk for a technology. I have risk for a project. These things are all within our architecture model already. So we don't have to create another environment, another tool, another thing to do that. What we do is we enhance the existing models with that dimension, these properties, so that we can monitor the risk for these various things. And if the tool provides computation and analysis, then you can do some very, very interesting things. Because you can go to, let's say, a business unit, and you can say, what is the highest risk that I face in this business unit, or in this state, or in this department? And that will highlight for you, okay, of all my departments, this one has a really high risk somewhere. Okay, then I can drill down through it and say, where is that risk? And I'll find it's this process because it relies on this technology which is obsolete. Okay, so we can pick up those things. You can ripple costs up to do those business cases that were mentioned earlier. If I'm designing this overall process, what services is it going to draw on underneath? What technologies are they going to draw on? And if we've got cost elements there, we can simply ripple that up and say, if I do it this way, my cost is so many $1 million. If I do it this way, it's half of that. Yeah? So it allows us to play those what-if scenarios. Moving to notation. Notation-wise, we've seen that we need to distinguish between domains and logical and physical. There's a very interesting candidate notation emerging from Telematica in the Netherlands. And from that research institute and an industry consortium has come a thing called the Archimate Foundation. And they have promoted a standard for architecture notation, and that is now being incorporated by the Open Group. So those of you who know about TOGAF, TOGAF does a very good job of prescribing the methodology for doing enterprise architecture work. Archimate is providing a standard notation which is service-oriented, which can be used very effectively with TOGAF. The TOGAF notation addresses services, processes, organization, products, information, infrastructure, applications, and functions. Just to give you an example, Here is one which has got 3 layers. Over here we've got, at the business level, we'll see actors such as the client or the insurer, and you'll see roles in terms of the roles played by different organization entities. So we've got a client and an insurant playing the role of taking insurance, and an assurer who is playing the role of an assurer. We've then got external business services. These are services that are visible outside the organization, and they are relying in turn on internal business processes. Those in turn are relying on externally visible application services, things which are available to invoke and combine. And those are relying on application components, which are the physical system elements that are available internally. They in turn are calling on available technical services that are exposed, and those are realized through particular infrastructure, mainframe, databases, and networks, and so on. So this is showing how, right from a very high level business picture external to the organization, we can trace down through business service, business process, application service, application component, technical service, technical component, all the way down. Yeah? So if somebody says to you, we want to shut down and upgrade this server, you can then say, okay, what does it affect, what does it affect, what does it affect? Ooh, we won't be able to do this while you're busy doing that. Yeah? Another example, different notation. This predates Archimate. What we modeled here was business events triggering business processes, those processes triggering other business processes, but waiting for example, an acceptance event. Underneath, we've mapped the application support for those particular processes, and you'll see applications being used to support multiple processes. And then underneath that, information. Again, information would support multiple applications, and then the applications run on various platforms down at the bottom. So again, you get a similar picture. Okay, now as I was mentioning earlier, if we put cost elements here and proportions of usage, we can then say something like, what will it cost us to run this process? Because we can ripple costs up from these elements underneath and get a figure. Or we can say, what is the biggest risk faced by this process? And if we map this down and we find the risks down here, we can take the highest risk represented by any of those, in other words, the weakest link, and we can find out why we're facing risk in a particular process and what to do about it. Yeah?